Hi, everybody. Welcome back to our DC location. And thanks once again to Secretary Will Roper for announcing our new strategic fund increases or the big bets. We're very, very excited about the 21 companies that have received these awards. And what we really do is we consider these companies to be some of the most promising small businesses that are rising up both within the Air Force and in the private sector. And what we see these strategic fund increases really as is this is one of our first large-scale attempts to build a sustainable and repeatable pathway for companies to go from that phase two, those medium bets across the acquisition valley of death and into sustainable revenue and into programs of record. Now, so each one of these companies, while Dr. Roper mentioned the amazing statistics about the hundreds of millions of dollars from both the government and from the private sector, there's more behind each one of these companies. In order to get to this stage, they had to pass through a grueling set of measures, more so than just submitting an application online. Each one of these companies that you're going to see go through here has five key components. The first thing they did is they've shown success in their medium bet, their phase two. So for all you companies out there working on your phase twos, knock it out of the park, because that's going to be your best bet in getting up into these higher levels of the strategic fund increases. The second thing that each one of these companies has is they have matching funds from the government, so non-SBIR matching funds. And so this is, once again, really making sure the customer really wants to see this thing transition, and so they're putting their own skin in the game. The third thing that they're bringing private matching funds. Now, these private matching funds, I want to be very clear. When we say matching funds, we don't mean only private VC investment or equity sales, things like this. We also have seen a number of these companies come through, and what they have is they've received most of their private funding through pre-sales or IP sharing agreements. So if you're one of those companies that does not want to sell a portion of your company but still wants to scale quickly, we absolutely want you to come work with us. Now, the fourth thing that each one of these companies brought was buy-in from a PEO, from the actual customer. So it's a program executive office. And so what they went out is they actually got a signed memorandum from a program executive office that said, here's exactly how we're going to transition this thing across the valley of death over the course of the next 4 years using these funds so that they go into a program of record. And then finally, they got buy-in from the resource sponsor, and that would be the MAGCOMs. And really the end users, because we don't want any of these companies to come through unless there's a real defense need with somebody on the ground, an actual operator, an actual end user who really needs one of these solutions. So each one of these companies has brought all five of those components, and they're really, really standouts from all of the existing SBIR companies that we have had go through this process. And so without further ado, we are going to have them go in rapid fire pitches, less than 5 minutes apiece. We're going to start off with 5 here in Washington, D.C., and then we'll go through the remaining 15 other companies virtually from around the country. And so what we will do next, without further ado, is I will introduce the folks from Aerial Applications.
All right. My name is Joe Sullivan. I'm very excited to be here today. I'm the CEO of Aerial Applications. Aerial Applications is a software company. Let's go ahead and get that next slide up there. Cool. Yep. And our vision is to make the physical world knowable. And so through this strategic financing, we propose 3 different ways of doing that. The first begins with hardware integration. We're partnering with 6 different companies to be able to bring to market a wide array of form factor reference devices. Second is Mapware, which is our software for visualizing and storing data. And the third is VAST, which is our software solution for analyzing large areas of data. Let's go ahead and hit the next slide. Okay, hardware. So form factor reference devices, what we mean by that is we'll be publishing a spec that allows companies to be able to integrate easily with our software. And we're very excited about this. We're announcing our partnership with Verizon and the 5G First Responder Lab to be able to put this solution together with a number of different American manufactured drones that will be able to leverage the rest of our software that I'm about to show you here. Let's go to the next slide. Yeah, so stay tuned for that as we develop. Mapware is our 3D environment tool. And what we do there is we aggregate all of the imagery that has been collected off of these drones, LiDAR, multispectral sensors, put them into one common operating picture that can be easily shared across the cloud in multiple different use cases and solutions. Next slide. And so the whole idea with this is that it's where your entire team can store and share geospatial data and have that common operating picture. Next slide. And then from there, we go into VAST. Slide. Yep. So VAST is our search engine for the physical world. And what we're looking at here is actual data that we captured during our proof of concept at Camp Bullis. So once you've flown the drone, you've captured it and constructed a 3D model, we give you this visual set of data. And then the next slide, infrared, and the next one, LiDAR. So there are multiple different types of sensor readouts that can be aggregated into that common operating picture. And where VAST really excels is in this next slide, where we take you through all of those different types of data, aggregate them into this node view. And if you go into the next slide there, what you can do is drag and drop in a codeless environment a complete artificial intelligence pipeline without ever having to know anything about code, anything about how machine learning or artificial intelligence is done. You can just pull all those libraries down and drag them into this common operating picture. And then from the next slide over, that will give you a coded view of each of the different things that you're trying to find in that map. And we're very, very excited about this because this means that for our MAGCOM, we're going to be able to solve environmental protection issues that they're having across 12 different bases and 39 different use cases that will help save the military, we think, between $12 and $16 million per year. And we're very, very excited about the impact on that, not only for the defense sector, but also for the commercial sector as well. Go ahead to the next slide. So again, hardware integration, Mapware to be able to view and store that, and then VAST takes you through data capture, data visualization, and data analysis to have that common operating picture and geospatial intelligence. Okay. Yep. Thank you.
Thank you very much. And up next, we have analytical space.
Hi, everyone. My name is Gil Valdez. I'm the business development lead for Analytical Space. All right, slide. All right, at Analytical Space, we believe the future of Earth observation and space-derived intelligence is real-time and on-demand. We are deploying the premier data transport layer in space in order to make this possible. Instead of needing to wait for an Earth-observing satellite like planets or Maxars to physically fly over an available ground station or communications cone, which is what happens now, our small satellites will collect their data while in orbit, and we will beam it hopscotch style through our in-space network and to the ground at light speed. Our network will give the world real-time access to every satellite that collects intelligence from space. We're designing specifically for high throughput and low latency, data ingest flexibility, high security, and global coverage. Will ASI be the fastest path to the ground for intelligence collected from space? Without a doubt. Slide. In addition to the in-orbit infrastructure we are deploying, we are building a two-sided marketplace. On one side, remote sensing satellite operators, and on the other are the end users of the data across defense, civil, and commercial. Because we have the ability to aggregate imagery from across multiple companies, we'll have the best diversity of imagery types with high revisit rates, from high-resolution multispectral through synthetic aperture radar. This is the ultimate capability that we're trying to deploy. In essence, we're making the surface of the planet immediately searchable. We become the one-stop shop for time-sensitive imagery. Connecting the world's remote sensing satellites is akin to the early days of the internet, where terrestrial communication infrastructure connected disparate data centers across the globe. Just as the internet made the digital world searchable, Analytical space will do the same with the physical world as observed from space. We've made significant progress. Slide. We made significant on the one back. Yep, we made some significant progress towards this vision over the last 4 years since we launched the company, including the completion of 2 technology demonstration satellites. We are working on our 3rd satellite, Cornicen, financed by our award at the Space Pitch Day in November 2019. And with this STRATFI award, we will initiate the deployment of our first full orbital plane, the backbone of the fast pixel data transport network. Slide. The Strategic Funds Increase program is a catalyst that will bring together ASI's private venture capital partners, commercial customers, and the Air Force Ventures team to commit tens of millions of dollars to scale our solution for government and commercial customers alike. This infusion of public and private capital will enable us to deploy the initial operating capability, an orbital plane of data relay satellites that can provide connectivity for over half the remote sensing market. Our service-based cost model is novel in the space systems acquisitions world, but because of the strong support of our early adopters and really visionaries, Major Lasorda, Lieutenant Colonel Stewart, Lieutenant Colonel Starr, Lieutenant Albright, Colonel Turnbull, and JT Thompson from the U.S. Space Force, we expect to swiftly deploy our initial constellation to serve the U.S. warfighter within 3 to 4 years. Let's look at what this means in practice for the end user on the ground. In this case, an Air Force combat rescue officer is trying to locate an airman that's down in the PACOM AOR. We envision a world where this operator could task any satellite connected to ASI's fast pixel network through their advanced battle management system platform and receive multi-sensor data through the fast pixel network directly to their tablet. Our network will be interoperable with existing and future DoD cloud, security, and other network providers to ensure path-diverse delivery of processed intelligence to the warfighter, even in contested or contingency scenarios. What this means for a downed airman is faster recovery time and prevention of capture by hostile forces, all because the ASI fast pixel network enabled their rescue faster than the adversary could locate them. We sincerely appreciate the support of Master Sergeant Strout for his support and insights as a potential end user of the fast pixel network. Slide. The future of Earth observation is real-time and on-demand. Through our data transport network, ASI is aggregating the capability of the world's Earth observation assets and enabling a complete real-time picture of the planet that we live on. Thank you for the opportunity to be a part of the STRATFI program, and we look forward to serving the U.S. Air Force well into the future.
All right, thank you very much. And up next, we have Anduril Industries.
So bottom line up front, Anduril is working with the Air Force Rapid Capabilities Office and the Air Force Strategic Development Planning and Experimentation Office to prototype an advanced multi-domain command and control capability. Our project is delivering transformational technologies and strategic capabilities to the U.S. Air Force, and we're solving a critical mission requirement of Air Combat Command by collapsing kill chains and enabling more rapid and effective decision-making by the Air Force and a joint force. So before I get into kind of the details, I want to talk about our principles of MDC2. Next slide. A multi-domain command and control system needs to be secure so that it can't be broached by adversaries who want access to all the information that you have and to understand what you have on them. It needs to be distributed so you don't have a single common point of failure. There's a lot of technical challenges in making a system like this. It needs to be autonomous, enabling beyond human capabilities and minimizing communications requirements and minimizing the reliance on communications always working in a degraded environment. An MDC2 system should also always be modular and interoperable. It should act as a platform for future hardware and software integration without vendor lock-in by any particular vendor. Over the past several months, we've had ongoing conversations with the RCO, ACC, and other mission stakeholders, kind of trying to explore their most pressing problems. And one of the common refrains we've heard is the need to tighten kill chains and enable targeting at superhuman machine-to-machine speeds. Next slide. We've been doing some work already on this. So our ongoing Phase II contract has been going for a while. We've been working with the Air Force Rapid Capabilities Office on an ongoing SBIR Phase II project exploring how artificial intelligence, virtual reality, mesh networking technologies, data, and sensor fusion can be used to further MDC2 principles and augment critical Air Force ConOps. Over the course of 3 4-month sprints, Anduril has already been working towards delivering an end-to-end MDC2 prototype that integrates multimodal sensor fusion, autonomy, secure mesh network comms, and C2 functionality into a single system that can be deployed during future Air Force multi-domain operations exercises. Our ongoing Phase II project has addressed a lot of different ACC mission requirements by first addressing ACC's need for reduced manpower, aiding air combat patrols through development of Catalyst and the introduction of autonomy to Group 3+ UAS, and addressing the ACC's need for tighter kill chains through GMTI, SAR integrations, and Lattice to enable machine-to-machine speed for find, fix, track, and targeting missions. I think that's FF2T2. So there's actually even more now. Now that we're able to expand our scope, things are about to get even crazier. Some of the key capabilities that we're now going to be able to develop and demonstrate in the near future are collaborative pre-flight planning and coordination between Group 3 UAS, GCS, and Lattice, dynamic and collaborative retasking of SUAS access by Group 3 UAS via Lattice and Catalyst, real-time data fusion detection and tracking data for specific classes of objects, being able to detect what something is autonomously and have the data share between lots of different systems, computer vision improvements and artificial intelligence improvements that will result in better detection algorithms for detection and identification of specific points of interest and specific targets of interest that you can either define before a mission or define during a mission. And then integration of all that mission information and data flow into the Lattice user interface and virtual reality command and control interface. On top of that, we're also going to be equipping a Group 3 UAS with a payload of air-launchable, attritable SUAS that can be command and controlled from that same UAS. So basically, you have a larger aircraft, it poops out smaller drones, and then it tells them what to do. Enabling a Group 3 UAS to receive missions from CMCC and Lattice to share that with that SUAS payload that it's pooped out. So it can autonomously coordinate mission priorities, determine tasking allocations per SUAS, and successfully execute and manage the plan that it sends to those SUAS. We're also going to be enabling an enduring architecture that'll scale capability and collaboration to include multiple Group 3 and larger aircraft, allowing each airframe to fly independent missions or to collaborate as part of a larger team, including other larger Group 3 plus aircraft and those autonomous smaller SUAS payloads that they will be able to launch from the air. Wrapping up, there are some key takeaways before I run out of time. STRATFI is enabling Anduril to accelerate the development of multi-domain command and control technologies with the RCO, as well as new UAS ConOps for Air Combat Command. Lattice and Catalyst are going to supercharge the abilities of our SUAS operators and UAS operators while streamlining manual information processes that today are very difficult for humans to manage. Single operators will be able to act as team managers, allowing Air Combat Command end users to more rapidly close their kill chains. And putting all these things together for the first time is really a transformational capability for the United States Air Force. It will increase the rapidity, efficiency, and lethality of Air Combat Command UAS. Thank you very much for your time.
Thank you very much. All right. I hope everybody got all that. Up next is going to be Centium. Let's see. Oh, there we go. There we go.
Awesome. Good afternoon, everybody. My name is Blake Teipel. I serve as the CEO at Centium, and we manufacture the world's fastest extrusion printers and the most comprehensive suite of high-spec aerospace-grade materials. And the combination of these two technology sets are now positioned, thanks to the STRATFI program, to join Team USA to be deployed at bases, depots, and service centers, not only in the United States, but also worldwide, so that we can keep America's airmen and women and the airmen and women of our allies able to service their aircraft quickly and increase their overall missional agility. We couldn't be more delighted to be here today. Thank you so much for your time. Go ahead. First of all, I'd really like to thank just some incredible people who've really just spoken into this process and really just kind of been the pathfinders for Centium so that we can figure out how to navigate just what is an incredible ecosystem with the DoD, but also an ecosystem that is unwieldy at times. So first of all, thank you so much to Dr. Roper for just creating the right program at the right size and at the right time. That type of visionary leadership is certainly what allows companies like ours to be able to, again, join Team USA and put our capital and our ideas and our technologies to work in ways that hopefully can generate a broad impact. Also, just, the incredible people on that team, Captains Benson and Lawver, and just the ways that the entire AFWERX team have come together and pivoted after the South by cancellation and provided just behind the scenes support for many, many months as we've put this program together. We got started by being able to join with Major Stoichi Goldberg at the Texas Military Department of the Air National Guard in ways to take a look at putting a 3D printer in a base and adding that to the machine shop in ways that increase the flight readiness for his own air wing at Lackland Base in Texas. And also, we were joined then by Mike Froning and the folks and his amazing team at LCMC EZP, Mark Benedict, his team at AFRL, and Nathan Parker and his team at RSO. And there are many, many other folks inside the Air Force to whom we are super grateful and excited to now be able to work with and help deliver this capability. So first of all, I just want to say, as we are in the outset of this program, Ascentium was walking into working with the Air Force with the knowledge that the Air Force has a bunch of new airplanes. We'd heard of the F-35 program, the F-22 program, but what surprised us was to learn, in fact, that America's fleet overall is actually fairly old. So America has a fleet of aging aircraft, and in fact, the maintenance and the support and the readiness for that aircraft is expensive, and it takes a really long time. So where we were able to figure out a way to come and be able to be of service was by bringing additive manufacturing, which offers considerable opportunity to enhance warfighting capabilities and create supply chain efficiencies, especially now in the third wave of additive. Just as Dr. Roper said earlier that the next battle will be between open societies and closed societies, what we're able to do is join with others in the additive manufacturing community to bring about open ecosystems, ecosystems that allow the freedom to innovate so that we can help advance manufacturing globally. So we are a small company that's growing now as a result of the STRATFI program and other efforts to become a medium-sized and a larger company in the future that can create an outsized impact. And due to the visionary STRATFI program and the support, we're eager to work to address these challenges. Thank you. Next slide. So I just want to highlight what this means. So when the rubber meets the road, how can advanced additive manufacturing really make a difference? So we toured the C-130 flight wing, and we noticed that whenever the wheels are being removed from the aircraft, you need to put on what are called thread lug protectors to protect that aircraft from damage. It's difficult sometimes to get those thread lug protectors on the wheel, at the right time. So that is an example of a service part which can be 3D printed to get that aircraft be able to be serviced quickly and back on the flight line as soon as possible. So where Ascentium comes in, using our high-speed extrusion technology, our revolutionary HSE, which is faster, it's between 5 and 15 times faster than any other solution on the market, we can actually create those parts, those 3D printed parts that you see in that column there, much, much more quickly than incumbent solutions. And the Air Force's own analysis has shown this is actually around 5 times cheaper as well. So that it allows the impact to be felt much more broadly. So another example would be an engine intake cap. We saw engines and transmissions that had been pulled from aircraft and needed to be serviced, but there are caps that need to be placed on the intake ports and various parts of the engine to prevent what's called FOD, or foreign object debris, from entering that engine or that transmission when it's being serviced. Okay, I need to go faster. There are many other examples of 3D printing that are helping to save time. Next slide. So we are scaling this through STRATFI. We're really excited about the AFWERX bridge and bringing this out to the rest of the world. Thank you so much for your time, and we're delighted to be part of that program. Thank you so much.
All right, thank you very much. And last but not least, we will go over to Voro.
Thank you. Well, thank you. This is Michael Campbell. I'm lucky enough to be the general manager for Voro Government Solutions. I have the opportunity to represent this fine company who's led by Mike Fong out in Phoenix, Arizona. Him and a bunch of very talented people that make all the stuff that we do possible. Next slide, please. So who wants to bring a phone to work? That's typically what we walk in with. People that work in government or sensitive jobs today have a restricted policies that allow them to, or don't allow them to carry phones in and out of their work environment. This is an ever increasing problem. Why is that? So in the Air Force alone, there is probably somewhere north of 200,000 accounted for issued devices, issued smartphones, tablets, etc. Pilots, 50,000 plus issued devices to pilots, 20,000 senior Air Force leaders, and then the remainder of just innovative people trying to get stuff done with their devices that are issued and the devices that they personally carry. So that arguably leads right to the first bullet there, which is smartphones and mobile devices are the future of compute. They allow you to do a lot more. Today, they've outpaced every other digital platform in terms of use for technology-related work. So that creates a problem. These things were designed to listen. For example, I had a friend who didn't believe me, and he had to sit there and talk about Levi's jeans, something he never says anything about. Next thing you know, his phone is giving him advertisements about Levi's jeans. He became a believer. They are built to listen, to make money. Listen and watch you. The other one is, if you want to mitigate that risk, software alone doesn't do the job. And then the people that build, the companies that build the smartphones, they're driven by a bottom line. as well as they have a supply chain that no one can completely control or trust. Next slide, please. So our people, our smart and very talented technology people know this. Technology security people know this. They have completely banned the devices. So that picture was taken at a government facility. The smoke break has been replaced by the smartphone break. Let's run outside, send a message, and then run back indoors to use the not so easy to use government system that we use at our desk. So that's one big, everyone in the intelligence community and DoD is being influenced by that problem. The other one is what I like to say is hope and prayer. So look, I can't carry it into my work environment, but I carry it everywhere else. But we know it's bad, so we're just falling back on what we hope is our workforce's ability to self-protect. I've had a top secret security clearance my entire life, adult life, and I know that people tap dance around sensitive issues. They carry these devices with them everywhere. They're typically using networks that they don't know who is monitoring or watching. Next slide. So solution, we've built an entire portfolio of capability. It begins with this very, very capable case that wraps around the phone to mitigate the risks. It connects to a cloud environment, which allows you to then put governance and other things in place so that you can use the capability to secure, better govern and watch your workforce, as well as add other capabilities. And it has other things as well that bring together a total portfolio of capability. Again, making the smartphone more trusted, more secure, the smart mobile device. Today, we are in use by numerous government agencies, and I wanted to, if you could zoom out to me, actually show a demonstration of the capability. So simple, right? Smartphone. So smartphone by Provoro. Smartphone is recording like it would be if you didn't know. Make sure it's working. So we're the 82nd Airborne. We're getting ready to deploy. We're going to leave on Sunday. We're going to take 2,000 troops. We're going to go to Ali Deed Air Base and blah, 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 XYZ. Boom. So when the hood was up, the protections are relaxed. You can use the phone. When the hood's down, the protections are in place. This is the minimum capability. So here we go. So there you go. We're able to allow you to trust the device, put you back with physical controls, and we connect to the governance systems that you have already in place that allows you to monitor that scale. So thank you.
All right, thank you very much. We're gonna sign out here in the DC Hub from the first part of the strategic fund increase rapid fire public pitches. Now back to the control team in Austin and off to the other STRATFI teams around the country. Thank you very much.
Thank you very much, Chris. I appreciate it. Dan Skinner, you are up next with Wicker. Are you on?
Okay, so you should be seeing my desktop.
That's correct.
Great. We recorded a video because we wanted to keep things on time and showcase a video that our partner Arma Global created for us. They're a G18 company helping take us to market. So I'm going to hit play now.
Perfect.
I'm Dave McKee. So you're the Air Force the last few months has been very efficiencies in the acquisition process, and the spirit of partnership working with teams at AFWERX and AFSOC has been very exciting and effective. AFWERX set a fast tempo and focused on dual-use solutions. AFSOC, as our sponsor, helped us define our product market fit. Industry and federal civilian customers are also benefiting from enhancements to Wicker funded by the AFWERX SBIR program, as large enterprises often have similar pain points. Next, a quick So that video ended with coming soon. To be clear, WICR is turnkey operational today and will be coming to a unit near you soon. As a result of the SBIR program, WICR now has multiple ATOs. The encryption has been validated by NIST, and WICR RAM is operational today. This central deployment eliminates the need for each MatchCom to host their own deployment and provides the most cost-effective way to purchase WICR due to volume pricing. Any unit, even Army, Navy, Marine Corps, can simply MIPR funds to Air Force for turnkey operational licenses without going through lengthy acquisition and deployment. WICR is way more than a chat tool. Chat tools are table stakes for communications. WICR has these features built into a single app and delivers all features using the same level of encryption. WICR is built from the ground up for the enterprise and has features you would expect to enforce your agency's policies, such as compliance logging, password complexity enforcement, single sign-on, Active Directory sync, etc. The mission-enhancing features are GPS location sharing, network traffic obfuscation, and censorship avoidance. Security is paramount. WICR is built on a distributed compute, zero-knowledge infrastructure. Our message security starts at the device, not the server, and is 256-bit authenticated end-to-end encryption with perfect forward secrecy, tunneled inside of TLS. Our zero trust architecture can tolerate a full backend breach without compromising message content. Our client security includes encryption at rest, ephemerality, anti-forensics, and network traffic obfuscation. WICR can operate across any network on the globe with confidence because every packet has 3 levels of encryption. Data is encrypted with a user key, separate device key, and separate key for the TLS tunnel. These 3 layers of encryption with different sets of constantly rotating keys provide superior security. Thus, users can be confident their data is private from source to destination. WICR worked with AFSOC and Arma Global, a GDIT company, to implement WICR RAM at Air Force. We are filling secure communications gaps. Not everyone has a satellite phone. Line of sight radios don't always have line of sight. Coalition partners are often on different networks. Email and DoD safe may not be effective for quick communications. So WICR has been implemented for recall, alert, and messaging. Hence, the name of our deployment at Air Force is WICR RAM. We are network agnostic, and the privacy of your data remains intact even on zero trust networks outside of DoD control, such as local cellular networks or the Roshan network in Afghanistan for that matter. There are a lot of consumer-grade apps with a degree of end-to-end encryption in use today, and these apps are much stronger than SMS texting, but still not strong enough for DoD needs. Most consumer apps were built for fun, not security. WICR has been deployed at scale as the approved solution to mitigate the use of multiple unapproved apps, which enables collaboration and improves situational awareness. Special thanks to Mr. K for encouraging us to pursue SBIR to begin. WICR serves millions of customers in government and industry for over 7 years. Here are some quotes from our end users.
Awesome. Dan, thank you very much. I appreciate that.
Thank you. We're happy to be making a difference and look forward.
All right. Up next, we have Steve Blumenthal with WAFER.
All right, thanks. WAFER is a rapidly growing, well-funded startup, and we're working on inventing the most advanced thin satellite antenna technology. Our antennas are ultra low power, low cost, and can be made conformal, allowing them to provide connectivity on aircraft, vehicles, ships, and dismounted people in ways never before possible. Our flat panel satellite antenna represents the lowest cost, widest bandwidth, and lowest size, weight, and power of any available steerable phased array antenna technology. Our ground terminals have been tested and are operating on geostationary satellites, and very soon we'll be operating with new LEO constellations. We're very glad to be working with the Air Force, and I'm currently going to describe 2 projects that we have underway. The first project that is well along is called the RAD-T, which is a small, portable, rapidly deployable flat panel satellite terminal designed for operation with LEO constellations. It can be vehicle mounted and used by disaster response teams or forward military groups. Lightweight, it's portable, and it has a very low profile for very low detectability. It has a rapid autonomous setup. It finds the nearby satellites, points itself, and automatically connects and tracks LEO satellites in their constellations. It has built-in IP router functionality and provides secure Wi-Fi internet connectivity, and it's very low power. It operates from a car charger. And then the other project that we're working on as part of the STRATFI program is to bring connectivity to the polar regions of the world. LEO constellations in polar orbits naturally provide excellent coverage for the Arctic and Antarctic regions. We are taking our flat panel terminal designed to track the LEO constellations and adapting it to operate in extreme cold conditions with very high reliability. We'll provide improved high data rate access to Arctic early warning radar sites and can also be used to provide better coverage and high throughput for NSF research sites such as the McMurdo station at the South Pole. We look forward to working with the Air Force on this STRATFI program, and thank you very much.
Awesome, Steve. Thank you very much. Awesome. I'm going to share you presenting capabilities. 1 second.
Thank you. Hi, guys. My name is Michael Amori. I'm the co-founder and CEO of Virtualytics here in Pasadena, California. And in case you're seeing us as well, behind us, we have our great team. And just a quick word, as a startup, our main priority is to number one, survive, number two, prosper. But besides that, it really makes us honestly incredibly proud to be able to help our country with our technology. So let me just give you a very quick introduction of the company and what we're doing as part of the strategic phase 2. So we're an advanced data analytics platform, merges AI with VR to help people find insights in data incredibly quickly. So the AI helps to find the patterns and the anomalies. It especially helps the non-data scientists. And the 3D visualization and the VR help people visualize those insights and then communicate them effectively to others. We are a startup that came out of research done at Caltech and NASA JPL. There are 3 parts to our technology. There is the AI, as I was saying, which helps find the patterns and the anomalies in large volumes of data. Does not require any coding. There is the desktop 3D visualization that allows users to see what the AI found and makes those insights digestible for humans. And then there's the VR part, which provides an incredible collaborative environment to share those insights with others. So as part of the phase 2, we were honored to be working with the Global Strike Command in helping them find insights very quickly in their data, in their B1 and B52 data. And so what we built for them was a way to pre-process and fuse both their pilot training data and their aircraft maintenance data, be able to merge those things together, clean up the data, understand what was important to them, create a customized user interface that at the push of a button allows them to pull in all those data sources and make them ready for analysis, and then pipe this data set into our software in order to allow them to visualize it, to use the machine learning that's embedded in our software so that they can make very quick and smart decisions based on the data. In the end, what really matters is, were we able to help our customer achieve something very valuable to them? And I think the answer was yes. We worked very closely with Global Strike Command. And in the end, our solution delivered a capability for them to find insights in their aircraft maintenance data and their pilot training data in about 70 seconds compared to the several days that it took with the previous process. Not only that, in some cases, we were able to find insights that would not have been available had they not been using our solution. And I think that's really important. One thing before I speak about the other things that we're doing in the DoD, as part of the strategic phase 2, we are basically going to do the same, we're going to come up with the same type of solution that we came up with when it came to the B-52 bombers. We're going to do that for other airframes, and we are going to add the ability to layer on predictive models on top of it.
1 minute.
So the basic idea is help Global Strike Command fuse the data, pre-process the data, and do that for other airframes as well. Now, we are honored to be working with several other parts of the DoD. So we're now under contract with Navy Special Warfare Command, with the Space and Missile System, with the Office of Naval Research, and with the F-35 program of the Air Force. With all of these projects, what we're trying to do is to enable a warfighter who can have data at its fingertips and be able to make decisions based on data much faster than with traditional tools. We all know that there's a lot of data out there. It becomes difficult for humans to parse it. Our solution helps humans parse through these huge volumes of data and make smart decisions very quickly and communicate it to others. Thank you very much for the opportunity.
Michael, thank you very much. Right on time. I appreciate it. All right. Up next, we have Mark Colby with Tectus Corporation, and on deck, we have Ben Longmire with Swarm Technologies. Mark from Tectus, are you on the line?
Yes.
All right. I'll be presenting capabilities with you here.
Next to kind of all the icons.
Can you see my screen and hear me?
We can. You are good to go. I will be giving you 5 minutes to present with a warning at 1 minute. If you're ready to go, we'll kick it off.
Distinguished guests, I'm Mark Colby, Senior Vice President, Government Business Development, retired naval officer. My job is easy because we have a truly disruptive technology with game-changing potential. Our company was formed 5 years ago on an innovation that took a Berkeley PhD almost 10 years to conceive. We have just over 80 employees, nearly 30% of them are PhDs. We've raised a lot of private capital. We put forward a 4X match to this program, not just a 2X. We hold a lot of IP. Notice the Mojo logo in the upper right. Since our tech is truly dual use, we have a government-facing entity in Tectus and a consumer-facing brand in Mojo Vision, but we are one and the same. Hollywood knew what we wanted the future to look like, but physics, engineering, and follow-the-pack mentality led us to awkward, socially and mechanically task-based devices on which to reap the promise of AR, that is, until today. Introducing the world's first invisible display. Tectus has created, against the grain, the world's only AR contact lens. Here, the Hubble lens is being shown worn by Mike Weimer, our CTO, but many more have worn it at our headquarters. Being an early prototype, Hubble provides simple text and image overlays to the world around the wearer. It's comfortable and safe to wear, which is a paradigm shift for AR, where other technologies are task-based, meaning they're worn for the task and then removed. Not so for our tech. Our user wears all day and commands the information into his view when desired. The rest of the time, he just lives in reality with corrected vision. So how fast can we improve this simple solution, provide game-changing value for the DoD? How about 1 year? Introducing the 2020 prototype Faraday. Now, I really wanted to show all the cool parts on this slide, but public venue really didn't allow that. But our proposal does show every single component. So for those who have access, it's a truly oh moment. So check it out. In this incredibly more capable lens, we still have the micro LED display, although with higher resolution. We've added batteries, magnetometer, accelerometer, gyro for eye tracking, processors and RF antenna for higher speed, and world's lowest power outward facing imager for things like facial recognition, language translation, night vision, and see what I see remote support. All this is covertly and conveniently for me today, hidden behind an iris camouflage and neatly sealed in an oxygenating scleral contact lens. As for future capabilities, I've already spoken to a few, but I'll highlight a couple more. On operations, swap down, SA up. This is truly an OODA loop accelerator. You can use your eyes to launch apps and control things like drones, and vectors like the direction to the landing zone for the very first time can be seen relative to eye position. On the medical side, imagine as a medic having remote support from doctors and surgeons in the field, or being able to look at a patient and see their medical history and vitals in a HUD. And from the support side, the Air Force needs a lot more pilot throughput, and on the training, you'll be able to see what they're seeing and accelerate those. Preventative corrective maintenance has also helped, as is remote tech support using See What I See feature. So we all want these, right? Yes, but it's not ready yet. We have medical testing, FDA approval to gain hardware engineering and software dev. But while we're using that private $150 million that we've gained access to, we have entered the STRATFI program with AFSOC, PEO, ISR Soft, and SOCOM S&T to do the following. System integration, we're going to work on software to integrate with ATAC and potentially other programs. We're going to create custom relay accessories for SOF, and we're going to do pre-FDA on-eye testing, which involves human subject research. We're also going to do FDA-approved product trials, deployment, and ultimately a transition to a program of record. Yeah, it's a lot to do.
1 minute warning.
We have a world-class leadership team, including Drew Perkins, our founder. He has successfully exited 4 companies in a row, and he's a serial entrepreneur from Carnegie Mellon. He's one of the internet's key contributors and inventors. Mike Deering, I talked about, founder architect, worked on this for 10 years, PhD from Berkeley in computer science. And Mike Weimer is a PhD from Stanford in electrical engineering. He's also a founder. And I can't address everyone else, but I will draw your attention to the lower bottom. Brian Lemoff, who's a PhD from Stanford in physics, will be the principal investigator for this project. The final thing I'll leave you with is, here's some of the things our customers are saying. They're very powerful and motivating to us, including things like potentially Air Force display of the future and game-changing warfighter capability and potential to give us an edge. We really honor these things. We thank you for our opportunity to deliver technology beneficial to the Department of Defense. Thank you all for your service and protection out here.
Mark, thank you very much. I really appreciate it. Up next, we've got Dr. Ben Longmire with Swarm Technologies. And on deck, we've got Orbital Sidekick. Is anyone from Orbital Sidekick on the line? Okay, Dr. Ben Longmire, we've got you up and you should have presenting privileges.
All right, yes, thank you. Looking to share the screen here. Okay, cool. So we're Swarm Technologies. We are a Silicon Valley company, venture-backed. We're 3.5 years old now, and we have 23 people. To date, we've been fortunate, and we've been able to raise $35 million. And we're looking forward to joining this STRATFI effort, working with Directorate of Special Programs at SMC. And we're excited to talk about two-way satellite communications. We have currently 9 satellites in low Earth orbit. This is a screen capture from this morning of their position. And these are test satellites, experimental satellites, doing two-way comms. We're able to communicate at the radio horizon, so just limited by the physics limit of our communication system. We communicate at 1 kilobit per second, and in late 2020, we'll be able to boost that to 2.7 kilobits per second. This is all done on VHF spectrum, Swarm was granted by the FCC and the ITU worldwide global rights to spectrum use. So we're going to deploy a larger number of satellites this year to complete a full global constellation for commercial purposes. For the commercial network, we'll have 150 satellites deployed. We have already purchased 170 launches of these satellites to account for rocket mishaps and any potential satellite failures. We're able to support millions of users on the ground doing this 2.7 kilobits per second two-way data communications. These communications can be ASCII hex data in the form of machine data, human-to-human data, text messages, emails, etc. This is a store and forward network. Everything is encrypted end-to-end. We have the unique ability to control our network's interface with the internet. On the commercial side, we'll be communicating to swarm-operated ground stations all around the world and flowing data through the internet. On the private network side, which I'll talk about in a second, we will be able to control whether that's person-to-person or flowing through the internet. Swarm is able to operate and launch on any launch vehicle. We've chosen a large number of launch vehicles now, and because of our very unique form factor, the small size of our satellites, while retaining a high capability, we're able to deploy an entire private constellation for groups like the Air Force. And we think the STRATFI effort is step one of this private constellation. Swarm is fully vertically integrated. These are some photos of what our lab facilities look like in Mountain View, California. We're just south of NASA Ames. And we maintain a clean room, build facilities, satellite testing facilities, and ground hardware facilities. The architecture is similar to other satellite constellations. The satellites maintain the network, ping ground devices, millions of devices can be supported. Swarm operates ground stations around the world, and the user can operate with 2 devices that will be rolling out, 2 hardware devices. And that interface can be easy through a cell phone or through a computer. The 2 ground devices that will be rolling out commercially, and we just passed FCC certification for both, are the tile and the tracker. The tile will be embedded into third-party devices, UGS, unattended ground sensors, for example. The tracker will be operated person-to-person and can transfer machine data or text messaging. And that interface is by cell phone or laptop. The tracker can last for 12 months in a deep sleep mode, toggling with a duty cycle to turn on and communicate. Just as a point example and use case for the Air Force in general, we thank you. We deployed a ground station in McMurdo Station, Antarctica, back in November. The environment is intense. We operated our first prototype of the tracker for a duration, an increment, a field exercise out on the ice. And in the background, you can see a C-17 Air Force cargo aircraft that we landed on the ice runway with. So we think, this program will lead to Air Force mission need solving of critical communications, dedicated network for specific missions, UGS, covert communications, and manned down systems. Thank you.
Awesome, Ben. Thank you very much. Right on time. All right, up next, we have Dan Katz with Orbital Sidekick.
But just so everyone knows, Orbital Insight is a location-based intelligence company. We are also privately venture-backed company that was established a few years ago. We established based upon the idea of the commercialization of space, with the fact that we understood that there's going to be an influx of data from all the new space-based providers of sensors. We worked together with the understanding that there would be an influx of those data sets and working with cloud computing to be able to process all that information. We wanted to work a lot with not just the data, but also understanding what that data means through artificial intelligence and computer vision science and data science to help understand what the data means to the analysts. We've been working very closely over the years with not just the Department of Defense, but also with the intelligence community. We started off working with the government through our work through In-Q-Tel. and eventually through DIU, and now with the Air Force and the SBIR program. We have offices out in Palo Alto, but we work closely with the government within our public sector team in the Washington, D.C. area. The company was established with the understanding that we can not only just support the commercial world, but also the government as well. We built out a web-based platform that is able to ingest massive amounts of data from not just commercial satellite providers, but also other data set providers as well, from drone technologies to AIS data to obviously EO and SAR data as well. And the whole idea is to be able to process all that information, bring it all together to a user's understanding, and be able to monitor a specific location and time over and be able to use that information to be able to provide information that will be useful to the analyst. In its essence, what we are doing is indications and warning, trends analysis, and change detection. We're able to do that through object detection, being able to monitor cars, trucks, multi-aircraft ships, as well as being able to do land use and change detection over time of how land is being used. In addition to that, we also do geolocation services. We're able to monitor movement of people and individuals through unique device counts and to understand how that's going to impact a location over time, and being able to use that information to provide analysts a good understanding of what is happening in that area as well. The thing that we're trying to do with this SBIR STRATFI is not just what we're doing on the commercial side and open internet and open intelligence, but also be able to transform that information onto the high side. So we're right now working with the 548th ISR group out in Beale Air Force Base and other units within the 480th Wing to be able to see how we can be able to move the information that we're providing, not just on open unclassified, but also where the analyst lives on the high side. We're able to use this information to be able to monitor aircraft globally. So if you will, if you want to be able to monitor every single aircraft in a specific AOR and see where these aircraft are moving, you're able to do that without any problems or being able to actually inflect it to be able to affect the workflow of the analyst. For example, if you wanted to monitor every single aircraft in Russia and being able to know what's going on in every single airfield in that AOR, using our AI technology and the platform, you'll be able to monitor those airfield in near real time and be able to provide understanding of where things are, where aircraft are moving, and be able to provide understanding of when there's changes happening over time and what that change might mean as well for the analyst to be able to interpret that data in a much more efficient manner. We also able to do that with ports. So whatever we've done with airfields, we can also do with ports, and be able to also monitor provide maritime domain awareness, and be able to understand what's happening through the commercial sectors of not just of ship detections, but also where the ports and monitorings of the ships over time. We're able to also do the same thing with land use. Being able to monitor what's going on with the use of land over time, being able to see how buildings are being developed, how roads are being moved, and how forest deforestation is occurring in certain locations. And this information could be used for disaster response.
1 minute warning.
Oh, that's fine. And be able to use this information for disaster response as well, being able to see how, if there are issues with regards to movements of hurricanes, of flooding, and being able to see how buildings are being impacted, if there are movements of people, as well as movement of physical activities as well. I wish I could be able to give a presentation and be able to show it to you and be able to also provide a demonstration, but if there are any questions about Orbital Insight, the work that we're doing, how we're supporting the Air Force, or through this STRATFI program, feel free to reach out to me. Happy to talk through anyone who has any questions.
John, thank you so much. I appreciate your flexibility to present here. For folks who have questions, feel free to utilize the chat section of WebEx. You can ask questions. You can connect with John there. So up next, we've got. Are you presenting? All right, we see you.
You see me. Okay, good. So I'm Ian Hersey from Falconry, and what Falconry is we call ourselves various things. Currently, AI.
Sorry, we're gonna have to move on to the next company. I'm up in queue. For Battleborn, Ian, will you be presenting today?
Sorry, I'm hearing background noise. Should I hold on a second? Okay, great. So falconry is about AI-enabled predictive operations at scale. We've called ourselves in the past a data scientist in a box, or insights on operational data without requiring data scientists. The whole idea is that you have this mass of data being produced by machines, some sensors, various forms of signal intelligence, but in commercial space, a lot of machinery in operational facilities, so manufacturing areas, steel making, metals, automotive, where you've got robots functioning. And what we're trying to do is bring all that data in, help organizations analyze that data and build predictive models that they can then run in their operations to uncover early warning of downtime potential or quality issues being introduced into the product. In the DoD and intelligence community world, we can also help the analyst community deal with large amounts of SIGINT in various forms. So really, overall, we're trying to help organizations maximize the impact of their operational data. We were founded back in 2012. We haven't raised a ton of money. The Series A was 12 million, and then we're doing another round as part of this STRATFI. We're based in Sunnyvale and Mumbai, and I'm actually on the big island of Hawaii talking to you, so aloha. What is our operational AI platform? You bring operational data in. These come from various systems that you might have, data historians, databases, various platforms that aggregate signal data. The key thing that we do first is all the signal processing and feature recognition, the feature learning. This is the hardest part of machine learning on multivariate time series data, which is technically what we do. So we learn all about the various features of each signal, including the size of the time window we have to learn, and then we can feed that into different sorts of predictive model generators. So we do unsupervised and semi-supervised machine learning on top of that feature data, so that we can map the time series data into labeled outputs that you see here on the right, to generate the insights that you need, and also provide explanation around what's going on in the signals. So simple example, novelty detection in mass inter ELINT. So step one, we build an unsupervised model and we automatically learn patterns from one entity in a limited time range. So here we're dealing with infrasound stations that hear various events. They're near the Utah test and training and test range. So there are explosions, rocket motor tests, et cetera. Without telling the system anything, we're able to uncover the various patterns that you see in this color line. So this is an unsupervised method. We don't know what to call them, but we know that they're distinct from one another, and there's an alternating pattern, sets of patterns in here. And this is a fairly noisy one, but if we then take the resulting model and apply it then to a new entity in time range, so things that it hasn't learned from, we see in this particular station a much more general or a much more regular pattern. There's only one of the ones present that we saw before, but we see a very interesting
1 minute warning
in red, which is an unknown event, and it turns out that that's an explosion. And that's something we learned without even telling the system what an explosion looked like. And so this use of anomaly or novelty detection has all sorts of applications. We work in various industries, and I will flow through that here. The focus of our current one, our STRATFI, is mass and ELINT exploitation use cases. And then we're moving from there into some predictive maintenance use cases where the instrumentation exists. So for example, weapon systems and modern digital platforms. Think of F-35s or various unmanned vehicles, and also POCing other promising areas like this application in cyber. Our lead partner has been the Joint Warfare Analysis Center. We have some other partners as part of this. They're classified use cases, so I didn't feel comfortable putting their logos up, but they're in other corners of Air Force and DoD. And so we're very excited to be part of this and to move forward with our customers.
Awesome. Ian, thank you so much. Appreciate it. All right. Up next, we have Sam from Enview. Sam, are you on?
All right, thank you. Appreciate it. My name is Sam Gunawardana, co-founder, CEO of Enview, here to talk to you about our efforts on tactical organic geospatial AI. I'd like to start by thanking our STRATFI partners, both within the Air Force and then across the DoD, Air Combat Command, AETC, Air Mobility, AFSOC, PACAF, SDPE, and PEO ISR SOF, and then OSD, RRTO, Army ASOL, and SOCOM PEO Special Reconnaissance. And this is a quite broad coalition of people that have come together to, I think, face a very similar DoD-wide challenge. And it's this challenge that data collection and analysis are widely dispersed and can't be rapidly tasked by end users. Right? Our current ConOps is a situation where we're at the point of need. We need an insight. We call up HQ. HQ will dispatch a theater asset. That asset will fly to the point of need back. Data will fly to the US, and then it will weeks and months later come back to the point of need. This is a very centralized, slow sort of process. We can change this now using technology, particularly when you consider the significant investments made by the Air Force in in-house organic data collection platforms, sensors, and compute availability. And this is what TOGA proposes to do, is to take this decision timeline, push it forward to the tactical edge, and get the insight time down to minutes and hours. This allows us to do some very powerful things. We think about the challenge right now of mission planning and other GeoInt type activities. It's a relatively old school sort of capability with old insights. Using new technology, we can really start to inflect this. And TOGA allows us to fully automate the virtualization of the battle space in full 3D. And this can be done at very high accuracy, very quickly, at massive scales, in a manner that is forward deployable and push button operable by an end user, that also has the benefit of allowing us to decentralize decision making. This is powered by some very interesting, unique technology. There's a lot of data fusion, particularly on the 3D GeoInt side, that is powered by a very powerful stack of AI, machine learning, and deep learning that lets us do 3D computer vision on 3D data sets. We do this in a very scalable, high-performance compute manner that is also forward deployable. I'll show some examples of what this means operationally. Enview has a pretty decent history and track record of deploying into the commercial sector, particularly within critical energy infrastructure. We have done some pretty amazing things as far as reducing decision timelines and actioning large data sets. Processes that previously would have taken 6 to 7 months now can be done in order 1 to 2 days. And this is the sort of capability increase we're excited to bring to airmen. So what can you do with this, right? You can start to get some very granular insights with this. This is showing now the ability to look at a 3D data scene, automatically label objects, ground, buildings, vegetation, power lines, vehicles, etc., and then use AI processes to find insights. And for this particular customer, this is a power line company. Obviously, this is a scary tree for a wildfire risk scenario, but you can find these very granular insights in very big areas through the power of distributed computing and software containerization. So being able to run compute in a scalable manner that lets you scale up to thousands of cores or down to a tough scale environment lets you have a lot of flexibility. And that does let you look at very interesting AORs. This is 5,000 square kilometers across the entire state of California, a high-res 3D terrain baseline with 3D structures, line of sight, et cetera, being calculated, all within the span of a couple of hours. This also allows you to do some very powerful things as far as genuine, meaningful change detection. So if we think about image-based change detection, it's quite challenging on 2D. So this is a before, and then I'll show after from a wildfire situation. It's hard for a computer to find the meaningful change based on the imagery. But on the 3D data set, what you're seeing here now is the volumetric 3D change in the scene. Green are trees that have been removed, or vegetation that's been burned out. The pink salmon things are buildings that have been removed. The dark blue are new vehicles, temporary housing, et cetera. And this is something that is quite robust and can be put into the hands of airmen. And so we're quite excited to think about Enview and see that it is truly, the TOGA is a one platform, many missions kind of solution. Our STRATFI partners are
1 minute.
Oh, thank you. STRATFI partners are excited to use TOGA for applications such as critical infrastructure damage assessment, adaptive basing, battlespace virtualization, HADR, mission planning, and cruise missile defeat, amongst others. I think there's a lot of places to explore and to apply this sort of capability, so I highly encourage outreach from people about how we can use TOGA to support different missions in your ConOps. As far as next steps go, we're excited to participate in the next APMS on-ramp and are very grateful and feel a lot of privilege and honor to have been considered and awarded for the STRATFI increase. Thank you all.
Sam, thank you so much. Appreciate it. Up next, we have David Merrill with Elroy Air. David, are you on the phone?
Yes, I am here. Can you hear me?
We can. I'm sharing presenting privileges with you now. You should see in just a second the option to share your screen.
Okay, how's that look?
That looks perfect. We've got 5 minutes. I'll give you a warning at 1 minute, and you're ready to go.
All right, thanks. Well, I'm honored to be a part of the Air Force Strategic Fund Increase Program. We are an aerospace and logistics company building a platform for autonomous aerial logistics and ISR. We've been working with AFWERX at Hurlburt Air Force Base in Florida and just jamming to get our systems ready for downrange. We've raised $10 million in seed. We're closing on more private venture now. So I want to start just letting you put eyes on our system in flight. We ran a flight test campaign at Camp Roberts in Central California in August, September, and October of last year. This is a 1,215-pound prototype aircraft flying on electric powertrain. And few teams in the world have built and flown a urban air mobility scale aircraft of this scale. So our software, avionics, and powertrain architecture are designed for robust flight, for redundancy, and long-range missions. So a little more about the platform. This is a hybrid electric VTOL system for unmanned aerial cargo and ISR. It's an open platform, so we're designing it to permit customizable payload pods, compatibility with GCS software, that works for the Air Force. We think of this like an autonomous Ford F-150 of the sky. Durable, dependable, designed to take a beating. We're designing this system for 300 pounds of payload and 300-mile range. And with AFWERX, the two key things we're working on are the ability to rapid deploy this system from a C-130, so it can be transported anywhere in the world for missions easily. And then also an ICD for the cargo pod to enable flexibility beyond just a stock cargo capability for new capabilities like ISR and electronic warfare. So, the key mission that we have been designing for DoD is for resupply, to sustain expeditionary teams in austere environments when ground and manned aerial resupply is dangerous or infeasible. And as I mentioned, we're developing an ICD so that customizable payloads can be developed for this aircraft platform. One of the really unique things about this system is that it's been designed for autonomy on the ground as well as in the air. So inspired by warehouse robotic systems like Kiva Robotics that runs Amazon warehouses, we have a division of labor between the human operators that pack the cargo pod and stage it on the tarmac, and then the aircraft system can taxi and localize the pod, pick it up, and fly it from A to B. And this means that we don't need human operators to manually load and unload the aircraft itself. And there are a couple benefits of this. One is an efficiency benefit. So the aircraft platform itself, the vehicle can stay in use over a higher duty cycle, so it doesn't have to wait to be loaded, wait to be unloaded. It also allows for delivery of payload to unattended locations where you don't have a person there to unload the vehicle. So this is possible now because of some recent pieces of enabling tech in this new chapter of aerospace. So for instance, flight controls and navigation systems that are getting good and low cost, hybrid electric powertrain, partially from automotive, and then sensor suite from autonomous vehicles like LiDAR and some very interesting radar and computer vision are all feeding into making this the right time to build this system. So our team is a very experienced group of experts in autonomous systems and software architectures, aerospace, industrial design, shipping, logistics, and supply chain. So this is really a bunch of pros that can build anything. Academic backgrounds from Stanford, MIT, Embry-Riddle, Georgia Tech, and then hires from Northrop, Airbus, Honeywell, Scaled, Blue Origin, AeroVironment, and some startups like Skyrise Airware. So this is a really diverse
1 minute warning.
All right, we're on the cutting edge of design in this new chapter of aerospace. So to wrap up, we're working hard to save lives on the battlefield. We're honored and stoked to be working with the Air Force, and the STRATFI is going to propel us forward faster than our commercial investors alone could to get our systems ready for downrange use. So again, we're honored to be here, looking forward to the expanded partnership. Thank you.
David, thank you very much. I appreciate it. Up next, we've got Dan Katz with Orbital Sidekick. And following that, we'll have Dimitri with Icon Technology. Dan Katz, are you on the line?
Yes, I am. Can you hear me?
We can hear you, yes. I'm going to share presenting privileges with you.
Fantastic. All right. Make sure I got that. All right. So
all right, we're seeing your screen.
Good. Perfect. Great. Fantastic. Thanks, everyone. My name is Dan Katz, and I'm the CEO and co-founder of Orbital Sidekick. And we provide global persistent monitoring services for the energy and defense sectors. Now, what I'd like for everyone here to do right now is quickly imagine a very, unfortunately, real-world scenario to play out here. So let's imagine we've just lost contact with a transport plane over the Sea of Japan, and we really only have a rough idea of its last known location. Fortunately, Orbital Sidekick is working to fully integrate with the Advanced Battle Management System, and our global monitoring service is immediately alerted to this situation. So Sigma, which is our global monitoring application, creates a target area surrounding the last known location of the transport plane and autonomously generates a corresponding satellite tasking schedule, as you can see here. So this tasking schedule is then uplinked to our 6 hyperspectral satellites in low Earth orbit, where they can begin capturing vital data over the last known location of the transport plane within hours or even minutes. So our hyperspectral imaging capability allows us to capture hundreds of very narrow contiguous color bands in the visible and infrared light regions. And because everything absorbs and reflects light in a unique manner, we can chemically fingerprint each target in our data set. Now, once we've captured this spectral data, instead of undergoing the time-consuming task of sending it back down to Earth for analysis and thereby wasting precious hours in this search and rescue operation, our satellites utilize a proprietary onboard processing capability for basically near real-time spectral signature matching and GPS registration. So here we see that our onboard processing has autonomously identified target signature matches for 3 pretty critical indicators when conducting isolated personnel rescue. So we got jet fuel, sea dye, and aircraft debris. So now again, instead of having to use inefficient, costly, and time-consuming traditional downlinking methods to transmit gigabytes or petabytes and terabytes of raw hyperspectral data, we can simply take advantage of existing space-based data relays, such as Globalstar, to send text alerts directly to the search and rescue teams. And again, this is due to our edge computing capacity on the spacecraft itself and our ability to provide actionable information directly to the end user. And obviously, we know that every second counts, and our ultimate goal is to bring everyone home safely. Now, this is just one example of our hyperspectral satellite monitoring service and how it helps the warfighter, and we're working on developing multiple product lines for tactical ISR. So STRATFI really enables us to rapidly deploy our 6 satellite constellation over the next 18 to 24 months. And this simply would not be possible if we were to solely rely on private investment. And our vertical approach of capturing data, rapidly analyzing it on our satellite platform, and delivering actionable information to the end user That was all born out of our commercial application, which is monitoring energy infrastructure. Specifically, right now we're monitoring oil and gas pipelines for regulatory compliance, leak prevention, and leak detection. And we also evaluate large spill areas, such as this oil terminal spill in the Grand Bahamas. This was last year during Hurricane Dorian, as some of you may remember. So we captured this data set with HEIST, which was our first hyperspectral imaging system on the International Space Station.
1 minute remaining.
Thank you. And today, we're now working with some of the largest energy companies in the world to start delivering value-added monitoring services on a global persistent scale. So we're incredibly excited to scale our capabilities with the STRATFI program. We're going to integrate fully with ABMS, and we're going to work with the fine men and women at Space Force, SMC, AFRL, AFMC, NASIC, and really the rest of the tactical ISR community. So again, my name is Dan Katz. Our team at Orbital Sidekick, we provide global persistent hyperspectral satellite monitoring for the energy and defense sectors. Thank you for your time.
Dan, thank you very much. I appreciate it. Up next, we have Dimitri from ICON. Dimitri, are you on?
I am, yes, sir.
All right, I'm transferring you presenting privileges. You should see the ability to share your screen coming up.
Okay, awesome. My name is Dimitri Julius. I'm the Vice President of Operations at ICON. First and foremost, I wanted to thank AFWERX and STRATFI for the opportunity to participate in the SBIR program. It has been integral to our success at this stage. And I'd also like to take a moment to recognize that the vast majority of the technological advancement that's taken place in this country over the course of the last 100 years has been in partnership and close ties to the servicemen and women of the United States Air Force. So we greatly appreciate that technology and the opportunity to leverage our technology in a partnership. With that said, what ICON does is leverages three things: advanced materials, robotics, and software to create a platform that allows us to 3D print structures of all different verticals, from affordable housing all the way up to bivouac shelters and forward operating base materials. And we're able to do that because of the digital nature of our design files. So with the agnostic nature of a 3D printer at scale, which our printer is 30 feet tall, about 28 feet wide, 15 feet tall, 30 feet wide, and 6 feet in width, which allows for approximately an 1,800 square foot print bed, if you were to kind of consider the constraints, which allows us to do a bunch of different things that currently weren't possible with bricks and sticks building. We have utilized this technology to impact the $2.4 trillion of open market space in housing. And we started our mission with a focus on sustainable, affordable, dignified housing for individuals in the Austin area who are experiencing homelessness. What we since learned is, again, due to the agnostic nature of the design file, we can design structures as long as they can exist in a 3D world, can exist across different parallels. So we've now had the opportunity to build at Community First Village, which is a housing area for individuals specifically dealing with chronic homelessness, all the way up to pocket neighborhoods just outside of Mueller, Texas, with middle market implications. And most recently, due to the partnership in the SBIR, we've had an opportunity to start working directly with the Air Force and the United States Marine Corps to start envisioning what the technology can do in battlefield scenarios. So a couple of the things that you get specifically when you're dealing with the rapidly deployable nature of a 3D printer is the opportunity to not only build forward operating bases, but a multitude of different structures, not limited to vehicle hides, hospital spaces, protective walls and barriers, HESCO type barriers, Texas barriers, things of that nature, and also bivouac sites. And so we believe that the forward deployable nature, the speed and the autonomy of the machinery allows for our men and women currently dealing with battlefield conditions have an opportunity to deploy this technology in a way that is both safer less troop intensive, and also allows for flexibility. And you can put this in the hand of junior troops and ensure that you're going to get a quality outcome. We also see, not only in combat scenarios, but disaster relief as one of the main missions of our servicemen and women, the opportunity to deploy these on the back of a C-130 or attached to a multi-ton vehicle and put them in areas that have been affected by storm systems. So think Hurricane Katrina, Hurricane Sandy, and some of the disasters that we've experienced on the Texas coast. This allows for us to make an impact in that area. Also, we have the opportunity to create mount towns and different training scenarios with this technology. And if it weren't for the opportunity—
1 minute warning.
Thank you so much. If it weren't for the opportunity to not only partner closely, but to get eyes on different training sites and locations, we wouldn't have made the jump specifically into military application. And so we're very grateful for the time, the energy, and the funding around this event, because it has allowed us to move through the phases from a startup in Austin, Texas, to a Series A company that is well funded and capitalized to do work with all branches of service in the near future. So thank you very much.
Dimitri, thank you very much. I appreciate your flexibility there. It's great to learn about icons. Up next, we have Adam Kaplan from EGBs. Adam, are you on?
Okay, great. So for those of you wondering what's with the name, we actually started as a gaming company, and we're happy to be working with AFWERX. Want to thank SOCOM and AFSOC for sponsoring us. So I think we're a great use case of how taking a commercial technology that started off in gaming and then worked in public safety. In certain cases, a picture's worth 1,000 words. In our case, video is. So here we look at a video or a picture here where we're about a software that's about situational awareness. And this is a case that in our software being used, in which what our software does is we geo-rectify data on real-time video as well as thermal imaging. And thanks to this award, also we'll be doing this on SAR as well. So in this situation, we're looking at a video during Hurricane Irma, where you're looking at flooded streets, looking at the tops of houses, information like these, and we're all about situational awareness. So what we do is we take this information and we geo-rectify data very, very accurately to a sub-half a meter level. So we take a situation like this and we can tag and fuse data in real time, such as street maps, blue force trackers, information like this. So in this video, you can see in real time the way we fuse these types of data and give that situational awareness to people in the air, people on the ground, in control centers and command centers. So the software is deployed in a number of public safety scenarios. We worked in Hurricane Irma, Hurricane Michael, up in Napa Valley. Most recently in Australia, software was deployed in New South Wales, where there were more than 1.3 million acres burnt, where we were able to geo-rectify where are burnt houses, where are houses that were not burnt, and we can take this data and then fuse it back to geospatial maps. So the software is being deployed, and in a number of these types of scenarios where we take this and we can take all of this data and in real time fuse that together with our computer vision and AI software. And we are hardware agnostic. So in particular, our program with AFSOC and SOCOM is focused off video coming off of MQ-9s, where we can take this information and in real time layer very, very accurately street information, mark where targets are, information in real time, where we can now take, instead of looking at multiple screens, you can fuse all that data and reduce the cognitive load for the pilots and the analysts that are viewing this real-time video. So in this scenario, you can see here where's the target, the incident command, and the blue force trackers. So these are scenarios, once again, in real time. And this is something that we are working very closely with the folks at AFSOC. In particular, we are in deployment now in Cannon Air Force Base at 27 SOG as one of our main proof of concepts there. So once again, in the MQ-9 environment, where you sometimes have 6 or 12 different screens, what we do is we reduce this now load and are able to fuse all of this data into one screen, where you're able to take in real time and understand, take the targeting data off of the reapers, take the understanding where the streets are, the pattern of life, and take a GRG and in real time fuse that over that video and give that situational awareness that's required for the warfighter. So this is all being done in, once again, real time, and it can be used in collaborative nature, looking at different drones. And in these types of situation, all of this information can be pushed down to the ground and to an ATAC device to give that awareness to also the folks on the ground. So once again, this is a little bit of a view as to what we're doing in the folks out in, this is an unclassed video, working off of an MQ-9, where we take this information and real time fuse that data.
1 minute warning.
Problem. So once again, we've had we're building out future capabilities. One of the future capabilities we're building out is actually the ability to disseminate SAR information, and we're able to take raw SAR visuals and then put that information in real time on top of that. So once again, we work in the commercial world. A little thing to show everybody, to show off some fun stuff we do, but also has a lot of applications. Here, we're also able to geo-rectify golf balls, which is what we did during the PGA tournament and during the PGA. So you can probably see there's a number of applications off of real-time FMV where this is also applicable for the Air Force. So once again, thank you, everybody. We've had a great time working with AFWERX, and we really appreciate this award and are very privileged to work with the airmen out in the world today. And I look forward to enhancing our capabilities during this program. Thank you.
Adam, thank you very much. Appreciate it. Up next, we have Steve with Applied Minds. Steve, are you on the line?
Thank you. So we are, our project is going to be to build what we call the National Space Defense Laboratory. And the idea here is that there is a national defense or a National Space Defense Center being stood up in Colorado to fight the space war through the, it's going to report to the Space Force. And we are trying to set up a laboratory in California that is going to be developing new tools and capabilities for the NSDC and develop them and prototype them and work them in the laboratory before they get moved over to the NSDC. And so you can see here we have sort of an initial graphic of what we think the lab might look like. There are three main things that we have that we think are important to be thinking through right up from the beginning. And so one of those is security. The space enterprise does have a lot of different security challenges, a lot of different security compartments. And so managing the fact that different people walking into and out of the NSDC, as well as the NSDL here, the lab, will have different accesses and things. We would like that all to be built in from the ground up. And so the lab will have an AI in it that is managing the security of the facility and the security of the space based on the people that are in it. Another thing that we think is very important for the lab is visualization. So the space environment is very counterintuitive for human beings. And so we have a significant activity that we've planned to go through looking at how we will interface the space environment to humans and how we will present it to human beings. We also have an AI working on that to be supporting, to be trying to present the environment as best as possible to humans that are in it. And then the last thing is just the interfaces. So a lot of, we'd like to bring new young people in, and if you think about sort of the standard interface, it's sitting on a normal government desktop, the KVM interface, keyboard, mouse, video monitor. A lot of the video games are now using gesture and other types of things, and so we are thinking through a lot of a lot about how we would like to allow humans to interact with the space environment through different interfaces as well. So we have one other idea that we've put in here, and it's part of the visualization, and it's something that we call auto director. And so the auto director is the idea that if you think about, like, if you watch a Sunday talk show, and there are people, you know, there's people being interviewed and there's questioners doing interviewing, you will see that sometimes the video will be shots of the people's faces when they're talking. Sometimes you'll do a pan out to the whole set. And there's a director in the background that's looking at the different shots and is selecting them, you know, based on his or her opinion of what will look best on TV. And so one of the other things that we're working on is the idea of an artificial intelligence auto director. Something that,
1 minute warning.
Something that will be taking the that will be making the shots as if there was a human director in there, so that when you're looking at the space environment, you will be getting the benefit of this director that is deciding what you should be looking at.
Awesome, Steve. Thank you very much. Appreciate your presentation there. Up next, we have Dexter Ng with Apollo Flight Research. Dexter, are you there?
Dexter Ng with Python here.
All right.
Can you allow me to share the screen?
Absolutely. Give me 1 second here.
Thank you. That looks good.
All right. Your screen is live.
Great.
Thank
you. Great.
Yep. Yeah.
Hi, I'm Dexter Ng, CEO of Python. Imagine a world where just by thinking of moving a finger, we could control all of the phones in our pockets or all of the complex machines and robots around us. A world where just by thinking of moving a finger, we could use the data generated from our body's natural physiological electricity activated by the brain to best understand one's health at any given moment. Here at Python, we are working hard to build this world. Python is creating an applied nerve sensing and insights platform to impact all of humanity. Over the past 3 years, we have built a system of systems that leverages the microvoltage that is captured at the top of any human's wrist to do many interesting things across multiple industries. For example, we use our Python device to help people with ALS who can barely move a finger to browse their favorite websites on a computer screen. We can use our Python device to help factory workers more safely operate the dangerous machinery they use. Most importantly, we also apply our technology to help those who have committed their lives to protecting our great country in every way we possibly can. Over the past year, we have determined that the most profound impact that our technology can have on this world most immediately, and thanks to AFWERX, Ensign, and our end user advocates, is on our armed forces and within the defense industry. Python's STRATFI product is a target rectification assistance for combat efficiency, or TRACE system, supported by PEO, ISR SOF, AFSOC, ACC, Air National Guard, and SOCOM. TRACE technology truly allows the Air Force Special Warfare operator to be heads up and hands-free through Python's patented electronography-powered gesture human-machine interface, and includes an ATAC plugin and hands-free UI manipulation of the Android OS and augmented reality, night vision goggles, and virtual reality. Our MOU from Colonel Luker, Senior Material Leader, states that TRACE aligns well to Special Warfare Assault Kit and also Guardian Angel programs of record. AFSOC and SOF have a national defense-related mission need in the area of visual augmentation systems and human system integration. The TRACE system enhances individual and unit survivability and lethality by empowering operators with the ability to access, employ, and control the tools available to them when needed and without disengaging from the task at hand. Our MOU from General Harris, AFSOC Director of S&T, states, Python's TRACE technology represents not just an improvement, but a game-changing warfighter capability. The TRACE device detects millimeter scale finger movements and enables wrist gestures and orientation tracking with machine learning utilized to increase compatibility and reliability. By doing this, the trace system allows operators to use gesture controls, inputs to their devices, while otherwise occupied, whether it be PJs with surgical gloves on typing out a message while providing care to an injured teammate, or a TAC-P or CCT JTAC, marking a target without interrupting their rifle fire. In addition to providing gesture control to Air Force Special Warfare, we believe Python can support every airman who uses a computer to do their job. Python allows maintainers on the flight line to use gesture to scroll through instructions and checklists while maintaining hands-on tools and tasks. Security forces to coordinate base defense plans and identify UAS threats by pointing to identify a threat location, and air crew manipulating electronic flight bags and kneeboard tablets while maintaining their hands on their flight controls, to name a few examples. Python allows Air Force personnel to maximize their focus on their core task. By using the Air Force as our beachhead into delivering lifetime value to military operators, we now have a robust system of systems to continue to take the cutting-edge technology we are building and apply it to various components. We already have clear visibility into what programs our applied nerve sensing platform can have long-term, multi-year participation in across other services that can also be commercialized in the consumer market with our partners, including Bose, Google, and Microsoft. Trace and STRATFI are the reasons that Python's technology development is catalyzed to make it to a point to impact the entire world. Thank you in particular to the AFWERX team, Steve, Matthew, JJ, Tony, Jason, others, Ensign, as well as our customers at AFSOC, in particular, Ray Heath at A5KB. Thank you.
Dexter, thank you for your presentation. Up next, we have Mike Slaw with Shift.org. Mike, are you on the line?
All right, thank you.
All right.
I think I'm last, but hopefully not least. First off, I gotta say, the other companies, it's just been incredible to watch the progress that's been made over the last few months and going through this process. Some incredible technologies that are being brought to the innovation force and to the warfighters. The future's bright. So for the past 3 years at Shift, we've been building a company that helps veterans navigate successful career change. And we're trying to redefine the way that companies hire non-traditional experienced candidates. Our vision is that we're going to make an impact on 250,000 vets a year per year by 2025. We facilitate innovative fellowship and skill bridge internships for transitioning military who are changing careers. We help veterans navigate career progression when they're seeking their next civilian opportunity. I'm the founder and CEO of Shift, and after serving in the Navy for 5 years as an EOD officer, I started this company. We're based in San Francisco and backed by Andreessen Horowitz and other leading Silicon Valley venture investors. Our hiring partners are incredibly diverse, and they're deeply committed to bringing more veterans into their workforce. They include tech businesses, advertising agencies, and Fortune 500 companies. Our current Phase II is a SBIR-funded industry immersion program. We're bringing together active duty service members, reservists, Guard, DoD civilians for a 6-week TDY and immersion at venture capital firms and venture capital-backed technology companies. We're building a platform for identifying high potential talent across the Air Force, and airmen are going to be able to engage in professional networks and trends related to specialized innovation practices. And as a result, private industry will also be more familiar with national security missions and how to engage with them. For the duration of the program, fellows spend 6 weeks at Bay Area venture capital firms and VC-backed companies. They do things like sit in on VC pitch meetings. They work on projects with general partners, which is just an unprecedented level of access. And most importantly, they're developing deep relationships that last far longer than just the 6 weeks that they're TDY in the Bay Area. The applicants were evaluated across 55 dimensions to include personality traits, achievements, and demonstrated capabilities. As a result, we were able to develop a completely new way to assess military talent through the lenses of creativity and innovation. And I'd be remiss if I didn't say just how excited we are with the level of quality of venture capital partners who have hosted and raised their hand to be amongst the first hosts for this industry immersion program. And we've seen over 100 VC firms present interest in hosting fellows in future cohorts. The STRATFI expansion allows development of an instrumented talent intelligence platform that's designed for us to learn quickly. It allows us to test hypotheses and collect evidence through the 50 cohorts of fellows and 16 executive seminars that we expect to run over the next 4 years. The platform is scalable, extensible, it's evidence-based, systematic, and it compounds over time. It supports both our commercial business and the Air Force talent and capability development. We expect a multi-year industry immersion program to deliver value to both the Air Force and private industry. But it's also supported by our technology development, and it supports our commercial business of helping veterans navigate career change to new industries. Aided by the first cohort of fellows, all of whom have a special place in my heart, and I consider to be trailblazers, we've already seen more than 24 companies on board in the SBIR process for the very first time. Here's what the future of the AFWERX program looks like.
1 minute warning.
Roger that. Over the next 4 years, we'll increase throughput to 300 fellows per year. We'll expand the programs to 6 major metropolitan markets of strategic interest to the Air Force. We'll host a 1-week executive seminar 4 times annually for senior leaders who have trouble breaking away for the full 6-week TDY. We'll host an annual conference to share best practices. And finally, we'll deploy an assessment and matching platform across the Air Force that provides a new way to find and assess the most innovative talent in the Air Force. I really appreciate your time. You can email me at mike@shift.org to learn more. You can sign up to receive program updates or apply for the next cohort, which kicks off June 1st, right here in Silicon Valley at 30+ venture capital firms. Thanks so much for your time, everyone. Hope you have a great rest of your day.
Mike, thank you very much. Everyone who was joining in, thank you for taking the time.